Today I want to talk to you guys about the local file technique. The local file is something that came up in conversation with Vince Bonanno and I when trying to solve a particular challenge on a project. The typical paradigm is that anytime a user is interacting with data, with maybe the exception of global fields, that is happening over the network between the FileMaker client and FileMaker server. What the local file technique allows you to do is to have the user alternatively interact with locally cached data in a separate kind of little baby FileMaker file. So what happens is every time the user logs in a container on the hosted file, there's another FileMaker file stored there. When the user logs in, we export that file to their temp directory, and that file gets referenced on the hosted application's graph, and the path is referenced via global variable, and it allows us to have that each user have their own copy of that file locally that they can interact with separately from the hosted data. Out of the box in FileMaker, as most people are familiar with, you get standard fields, which are great. Store your data as any relational database should. They're searchable, they're indexable, they are relatable, they have the ability to have rather complex relationships and across different tables set up. All those things. Global fields, on the other hand, are great because they are session bound. They don't require communication back and forth to the server. They're unique per user. What the local files do is basically have the best of both worlds in that regard. We can have whole tables full of fields and a whole bunch of multiple records potentially, all that are unique to that user. So it allows us to have a whole bunch of flexibility from a UI perspective where the user can have, rather than storing, for example, UI state in global variables, you can store it in unique records, which can be related to a specific hosted record, which allows for a more robust user experience. Data integrity is a huge advantage as well because you can have the user be able to load that data into the local file where they manipulate it, and then once they've completed all of their changes, save them and push them back to the hosted data. From a performance standpoint, it allows us to limit network traffic. If we're taking them out of the data stream, so to speak, where they are now only modifying the data locally, that's cutting down a lot of network traffic. If you have users who are accessing the application remotely, that's a huge advantage. It's really not nearly as complicated as you might think. The add-on that we built adds a table with the container field and has scripts that you can add to your OnFirst window open to export the file, and adds a table occurrence, at least one table occurrence to the local file to your graph for you. So you kind of are ready to go to start developing tables and fields in the local file and start using them. So a quick demo of what I'm talking about here. This is the application I built to demonstrate some of these techniques at Engage. So we have pair computers, and we have a list of stores on the left. And the middle column, we have employees in a given week and their shifts and the shift length for those days. Here's the week selector. So I can change this to week 10, 12, 10, and you can see that the shift's changed. Similarly, I can search employees and filter the list down to a specific one. So let's look at Tate here. I can click on Tate and get his specific details in the right-hand column. So now, if I go to a different store, Canary Park, notice we're on week 1126. I can go and filter to some other employee. Let's say Mendel. Select him. You can see his details on the right. So I'm on week 1126 looking at Mendel. If I go back to Buena Vista Hills, I'm still looking at Tate, still looking at the week of 1210. And I get that for free without having to do any juggling on record load or anything like that. It's just remembered because that is a part of a record that is actually stored in a related local file record. So I can clear the state here, select somebody else, go back, the state is still remembered. Even more fun, let's say we're looking at Buena Vista Hill here in two different windows. And you'll notice already I have it filtered to Tate and Tate selected on the left, but I can be looking at different weeks, have different selection states, different filter states, and there's no change in the other window as I do that. Because this is, again, not relying on global fields, it's relying on data that is stored in local file records. So it is unique per window per store record. And just a further point, I can change the filter here to something completely different, select different employees, all those things without having it contaminate the UI experience of the other window. The next use case would be enhanced, kind of more complex record editing. Let's say you have a purchase order or something like that, and you want to quarterize, the amount of spend on that purchase order or project, whatever the case may be, across multiple quarters. But obviously the sum of all those quarters has to always add up to the total value of the project or the purchase order. The problem with doing that natively, if users are modifying individual records, there's going to be at least some implied commit between each of those modifications. For some point in time where the state of the child records is not going to add up to the total of the parent records. Another user of the system could at that particular moment come in and decide to run a report, and you might have data that's not currently accurate and could cause reporting problems, bad business decisions, what have you. The benefit of using the local file is that you can take the records out of the data stream. User can make all their changes at once. You can validate all those changes as a batch rather than individual commits. So a quick example of that here, you have a little edit button here. We're going to click that. That's going to grab all of the data for these shifts for this week as JSON and load them into records in the local file. So we have all of our employees here and then all their shifts by day. And you can see here I have an accordion view. Again, this is something I can do in the local file using subsummary parts, specifically because this is unique to my session. So by clicking these, I'm actually modifying record data to make that happen. Here, let's delete this. Let's add this shift on Tuesday for Tate and delete his Monday shift and add another one on Thursday and save. Looks like one of our shifts doesn't have an end time. So it's doing validation across the entire data set before we save. Again, none of this data is going to the server yet. It's all happening locally. So it's all tentative, local to my session. But let's just say, you know what, never mind, I want to abandon my changes. I can reset and just reload all the data from the initial state. And now we're back. And if we look at Tate again, you'll see that his shifts are back on Monday and Wednesday, nothing on Tuesday or Thursday as we had before. But let's put that Tuesday shift back in, delete Monday, and save. And if we look down here at Tate, you'll see he now has a shift on Tuesday and Wednesday, but not on Monday. So let's take that one step further. We only modified one person. Granted, we modified multiple shifts, but let's say we want to modify multiple employees with multiple shifts simultaneously. We can also do that. So let's delete a whole bunch of these shifts here for Jody. Put some different ones in for her. Collapse Jody. Let's go back to Tate and added another shift for Tate as well. And now we should be able to save the change to both those employees. And you'll see that Jody has 2 shifts and Tate has his new 3rd shift on Thursday. So I would say another benefit is just performance generally. I talked about minimizing network traffic. For users or people who are building applications that is being accessed over a LAN, probably not necessarily a huge consideration. But for those of us who are building applications that are being accessed over the WAN, the less time that the client has to communicate with the server, generally speaking, the better, because latency can be a big killer of performance in an application. So these are some basic comparisons I did, just tracking the number of calls to FileMaker server being made for a given action. In this case, modifying a single record, modifying multiple fields in a single record with a commit in each one, modifying 5 fields in a record and committing at the end, 1 field and 5 individual records. And last is modifying a parent and 5 children via a portal. But you notice in each case, writing a script that packages up those changes and then sends them to the server to be modified, rather than trying to do it locally, is far fewer calls than the native back and forth of entering those fields. This is related to that and why it kind of matters. FileMaker is actually pretty bandwidth efficient in my testing, but latency can really kill performance. So this is a rough graph of network latency in milliseconds versus time it took to execute a particular operation. And notice that it's an exponential scale, not linear. The more remote your users are, the higher latency their connection is, or the worse their connection is. They might have plenty of bandwidth, but high latency. And that can have a really outsized impact on the performance of the application for the user. So the less communication there has to be back and forth between the user and the server, the more they'll feel it'll be an exponential improvement for the user experience. What are some questions I've heard come up over the last 6 years since we started using this technique? Isn't maintaining 2 separate FileMaker files a bit of a challenge? It's not quite as bad as you think it is. Because the sandbox file only contains tables and fields, and maybe a few relationships to drive calculated fields, for example, everything else happens in the hosted file. So you really only need to add what you need to support whatever it is you're trying to accomplish in your particular application. You don't need it to be a complete, you don't need a copy of every table in your hosted file, in your local file. You just need the ones that you want to use for this. There's very few relationships because you only need the ones in there that you would need to support calculated values potentially. And then last but not least, everything is hosted. And I really can't emphasize this enough because I did not have this realization until about a year into using this technique. Almost everything can live in the hosted file. You don't need value lists or layouts or any of that stuff in the local file. All that lives in the hosted file and just references data in the local file. So another good question that comes up often is, well, what do you do about record conflicts? If you're taking users out of the data stream, you are losing the record locking, the normal record locking capabilities of FileMaker. So how do you account for that? Well, it's kind of up to you as the developer, is the short answer. First option is could use it just to enhance your UI UX and not use it for manipulating data. What we typically use is last in wins. Most of our projects end up lending themselves to that methodology. For example, you might have a project management tool of some kind where each project has a project manager. So it's unlikely that 2 users are going to be modifying the same record. And so last in win in that case tends to be fine. That said, we do have some that don't fit that paradigm. And in those cases, we have to decide some way to manage the record state. So that could be marking the record on the hosted side as checked out, or comparing the state of the hosted record to what the original state was when you started your edit to make sure that no changes have happened since you started editing. There's other options as well, but those are 2 that we tend to lean towards. Another question that I've seen is, does this work in FileMaker Go? And yes, it does. It works just fine in FileMaker Go. FileMaker Go has no problem using the temp directory. And this demo that I have shown today works just fine in Go on iPad. Another question that comes up is, does it work in WebDirect? Yeah, no, it doesn't really work in WebDirect. The reason why it doesn't is because, as most of you will know, WebDirect is rendering your FileMaker application on server and then just serving it up in the browser. So there isn't really a temp directory to speak of, certainly not a local one. So why use the sandbox file versus any other viable technique? Well, this is meant as an arrow in your quiver, not necessarily a catch-all for it solves all of your problems. It's meant to be kind of super global fields, basically. It's meant to give you globals, except with the benefit of records and tables and relationships and individual fields and things like that. So when would you use it versus global fields? I would say anytime you're trying to manipulate more than one record at a time, or where it's important for a user to be making changes to multiple fields simultaneously, the local file starts to make sense, just because you can have the ability to have as many fields or records as you need in the local file for them to interact with, and then process all those changes together, as we talked about earlier. Separately, obviously, all this could be done in a web viewer if you're a savvy enough web dev, but for the rest of us who are a bit more FileMaker oriented, this is a near native way to just get more capability out of the platform.